Hi, we are going to look at applications of exponential functions, so pretty much word problems. And let's get started. Before we look at word problems, we're going to look at percentage increase and decrease. This is something you would have done in grade 9, but it's a good idea to come back and recap this. So for instance, if you wanted to calculate the 20% increase on a $200 item. Okay, so this is the original value, that's $200. And then there is a 20% increase on that $200. What is the final value is the question, okay? So to do that, we are going to, we're going to do $200 plus 20% of 200, right? So 20% is the same as 20 divided by 100. So in decimal value, that is 0.2, okay? So when I say 20% of $200, so basically 0.2 times 200. So that is 200 plus 0.2 multiplied by 200. Okay, so this is the long method that actually explains what you're doing and in without any shortcuts, right? So when you do that, for every $100, that is a $20 increase. So 0.2 times 200 is $40, right? So that is 200 plus $40. So that is $240. So if something started at $200 with 20% increase, it would become $240. Okay, so that is what we mean by percentage by increasing by 20%. Now, the same thing we can also do for 5% decrease. Okay, so for 5% decrease, we are going to subtract. When it is increasing, right? When it is increasing, we add the value. When it is decreasing, okay? So when it is increasing, we add the value, right? And when it is decreasing, we subtract the value. That means if I again start with a $200 item, 200, and now I'm going to do minus, okay? Because of decrease, I have to minus, and then 5%. 5% is 5 divided by 100. So 5 divided by 100 multiplied by $200. Okay, so that is $200 minus $5 for every 100. So basically $10. And then, sorry, pardon me, I am sneezing a little. Um, sorry, that is $10. Okay, so that is $190. 12% decrease would be, so this value here is 0.05, okay? For 12% again decrease, okay? That means it's a subtraction. Whenever it's a decrease, you're taking the amount out. So $200 minus 0.12 times 200, okay? And for every $100, it's $12. That means for $200, you're taking out $24. Okay, so 200 take away $24, which would be 176, I believe. Okay. So far, there's nothing extremely new. It's all it's all what you've already done in grade 9. Okay, we're now going to use a multiplier, which you might have also done in grade 9. So for 20% increase, the multiplier is 1 plus 0.2, which is 1.2. What does this multiplier mean? This multiplier means I can just take $200 and multiply it by 1.2. Go ahead, get your calculators out and try it out. It should give me the same answer of 240. Okay, so this answer and this answer are exactly the same thing. Okay, it should be exactly the same thing. Okay, so this and this are the same. Same thing over here for 5% decrease. Okay, for 5% decrease, what am I going to do? I'm going to do 1 minus, not plus, but 1 minus 0.05, which is 0.95. So that is $200 times 0.95, which should give me $190. Okay, just double check your use your calculator and double check. So this value 0.95 is less than 1, right? Whenever you have this is your multiplier. Okay, you see your multiplier. Your multiplier is less than 1 when there's a decrease, and your multiplier is bigger than 1 when it's an increase. Now, for 12% decrease, 1 minus 0.12, okay, and your multiplier is going to be 1 minus 0.12, which is 0.88, and that's your multiplier, okay? This is your multiplier, right? So basically, $200 times 0.88 should also give me 176. Okay. Now, this multiplier is a very important part of this lesson because that is the one that we're going to use for our exponential growth and exponential decay, right? Let's try this out. You can pause the video and actually ask someone beside you whether they got the same answer. And meanwhile, I'll write it and you can check your answers after a few seconds. Excuse me. All right. I hope you've paused and checked your answers. Okay, moving on. Now, in the previous lesson, when we did exponential functions, we looked at the parent function as f of x is equal to b power x, and the base can be different. And b is always bigger than 1. Sorry, when b is bigger than 1, we get an exponential growth. And we also saw that when b is between 0 and 1, there's exponential decay, right? We're also going to have an initial value of a, right? So if I write it as y is equal to ab power x, what does that mean? When x is equal to 0, what happens when x is equal to 0? Then y is equal to ab power 0. And b power 0 is equal to 1, right? So that is going to be y is equal to a when x is equal to 0. That's why it's called initial value. So when you have a multiplier in front of y is equal to b power x, or f of x is equal to b power x, that multiplier is the initial value, basically what happens when x is equal to 0, okay? I also want you to get used to your graphing calculator skills, so make sure that you use your graphing calculator and use this. Just type this in and see what you get. Go ahead. I'm going to grab my graphing calculator and do the same thing. The reason for this is because when we start doing questions, I want you to be fluent with your calculator skills and not be searching for where's the exponential button and stuff like that, and also paying attention to order of operations and stuff like that, right? Okay, check if you got the same answer. Well, what do we do with this? We're solving the exponential equation, so we have to first rearrange this equation. How do you rearrange this equation? We want to get n naught by itself. So basically, you're going to write n naught is equal to 500 divided by 1.25 to the power of 1.25. 0.25. Or we can first calculate this bit here, okay, and get a numerical value and then divide it out, okay? Either works. So try that out. That should be 378.2966 something, okay? Sorry, I'm fighting a bad cold. Pardon me. Right. Now, this is the part you need to be very careful and pay attention to this a little more closely, okay? Now, the b value, okay, in y is equal to ab power x, right? Y is the dependent variable, right? And then a, we saw on another slide, is the initial value. B is the growth or decay factor. That means basically if it's an increasing graph or a decreasing graph. And then X is the independent variable, okay? I'm not writing that because I'm running out of space, or maybe I can write it. Oops, sorry about that. Where did my screen go? Okay, sorry about that. There we go. Okay, and yeah. So, and X is your independent variable. So, is this an exponential growth or decay? So, your A value is 20, the B value is 1.02, and B is bigger than 1. If B is bigger than 1, it has to be an exponential growth. The initial value is the A value, which is 20. The growth or decay rate. So this is probably going to be a little confusing for some of you. So pause and think for a few seconds. 1 plus, so actually the B value is 1.02. B is 1.02, which is 1 plus 0.02, right? That 0.02 is coming from where? It's coming from 2 divided by 100. So that is 2% growth. Okay, so the rate is 2% growth. Okay. Here, for the next one, B is 0.8, which is less than 1. So it's an exponential decay. The initial value is 1 because there's nothing multiplying here, which means it's 1 multiplied by. Growth or decay rate. So 0.8 is 1 minus 0.2, and 0.2 is 20 divided by 100, so that is 20% decay. Okay, so that means it's decreasing by 20% every time. Okay, that means every time the independent variable changes, the dependent variable decreases by 20%. The next one, B, is 3, which is bigger than 1. Okay, and it is an exponential growth. The initial value is 0.5. Is it a growth or decay? What is the growth rate? 3 is 1 plus 2. How do you get 2? That is, multiply that by 100. So that is 200% increase. Okay. The next one, B, is 5 over 8, which is less than 1. So it's a decay rate. The initial value is 600. 5 over 8 is basically 1 minus 1 minus what? 3 over 8, right? So 8 over 8 minus 3 over 8 gives me 5 over 8. So that is 3 over 8 times 100% decay. So what is that? If you put that in your calculator, you can that's 3 divided by 8 times 100. Sorry, I typed in something wrong. Give me a second. There we go. That is 37.5%. Actually, it's an exact value. So that's 37.5% decay or decrease. Let's just use the word decrease, okay? Right. The next one, we are going to do a small word problem. The growth in population of a small town since 1996 is given by the function. When there's a function, what is the initial population? Explain how you know. So the initial population is the initial value. So the initial value is, so if you do y is equal to ab power x, okay, this is your initial value. So that's 1250. And then that's 1.03 to the power of n. And this is p of n. Okay, so pretty much that's what you're trying to do. Okay, so the initial value is 1250. That's the initial population, right? What does initial population mean? Initial population is basically the population in the year 1996, because it is from 1996, right? The initial population is 1250. That is in 1996. That's a very small town, right? That's the probably number of people living in an apartment building in Hong Kong. Right. So 1,250 is a population in 1996, okay, or in the year 1996. Right. For the second part of the question, what is the growth rate? So we're going to use the growth rate as so 1250 times 1.03 to the power of n, right? Your b value is your growth rate. So that is your b value, right? So b is 1.03, right? So that is 1 plus 0.03. Okay. So b, this gives you the growth rate, right? So this gives you the growth rate because it's growing, it's a number bigger than 1. So 0.03 multiplied by 100, what is that? 3%. 3% growth. That's not bad, actually. You know, in many parts of the world, the population growth is probably 1.5%, 1.7%, 1.2%, maybe except in some countries where they're probably having more than 3 kids. Okay, so very few countries, that is. Right, so that is the population growth rate in that town, okay? They're probably busy trying to make the town bigger. Okay, next, determine the population in the year 2007. Okay, so we have population P of n is 1250 times 1.03 to the power of n. What I don't want you to do is you're not going to put 2007 over there, okay? What should you do? They're asking the population in the year 2007. So don't go writing 2007 for n, because that won't be correct, because n is the number of years since 1996. Right? So 2007 minus 1996, and that is 11 years. Oh, sorry. Okay. So then you have to say the population P of n, or in this case P of 11, is 1250 times 1.03 to the power of 11. So put that into your calculator. Which is 1,730.29 people. Okay. One person is still not born. They are somewhere 1/3 of their life on the earth. They have not yet started. Okay. And then so that was the answer to part C. Part D to this question, in which year does the population reach 2,000 people? For this, there's an actually easy way to do this using logarithms. But since I haven't taught you logarithms yet, we have to use the guess and check method. Okay, and let's try that. So when does the population reach 2,000 people? Okay, so 2,000 people. Okay, basically they're asking which year. Okay, what we're going to do is we're going to say 2,000 is 1250 times 1.03 to the power of n. Let's see. Over here, on the 11th year, there were this many people. So the numbers definitely got to be bigger than 11. Okay, we're not going to double it because it's an exponential growth. That means it's growing by a percentage. That means it's going more rapidly, right? So what we're going to do, so going to try maybe 14. Why 14? I have no idea. I'm just guessing, okay? So I'm going to use the guess and check method. There is another method using logarithms, but we'll get to that much later. Not much later, maybe a week or right after the spring break, okay? So guess and check method, okay? Say n is equal to 14, okay? So let's do 1250 multiplied by 1.03 to the power of 14. What does that give me? This is where having your graphing calculator really helps so that you can go and just copy the equation and keep editing the exponent instead of typing the whole thing again, right? That is 1,890.73. What happens if I try 16? Okay, so again, just copy the previous step down and just go and edit the equation on the exponent. Oh, that for 1, 2, so that's one value. The other one is 1250 times 1.03 to the power of 16. I ended up getting 2005.88 people. Okay, that's a lot. Okay, that's a lot more than we're looking for 2,000 people. When does it reach 2,000 people? So we're going somewhere between 14 and 16. Let's try 15. Okay, so 1250 times 1.03. As I told you, it is a guess and check method, so that's what I'm using right now. So that gives me 1,947.45. Well, not exactly 2,000. So we have to go 15 point something. Okay. Is there a more efficient way to do this? Certainly, yes. Okay. Mathematicians are not going to be sitting and crunching numbers like this by guess and check. Right. So 1250 times 1.03, 15.5. Okay, so you can copy, paste 15.5. Oh, that doesn't quite make it either. 15.6. It's still very low at 15.5. Okay, let's say 15.6. At 15.6, at 15.6, I have 1,982 people. At 15.7, I have 1,988. At 15.8, I have that didn't work as well. It's coming very close to 16. Okay, so 15.9. Maybe 15.9. Okay, so I'm going to go 15.95. Okay, and see what happens. Okay, that 15 point. So basically at 15.95, I have um I have 2,002.92, and at 1250 times 1.03, 15.9 9, I have 1999.96. I'm going to kind of pick this value, okay? So n is equal to 15.9. So which year is that? So basically, you have to go from 1996 plus 15.9, okay? So, and then you would go 1996 plus 15.9, and that is going to be in the year 2011, 2011 plus 9.9. What does that mean? 0.9 is 0.9 of the year, okay? So 0.9 multiplied by 12. Why 12? Because there are 12 months to a year, right? So 0.9 multiplied by 12 is going to give me 10.8, okay? So somewhere towards the end of October, right? So somewhere towards the end of October, you're going to end up with, um, you're going to end up with 2,000 people. So approximately somewhere towards the end of October 2011. Okay, so that's your answer. Okay. Yeah, so that is all I have for your lesson today. And then you can work on your homework questions. All right. Actually, please try this. Uh, please try this question. Which of these you can pause the video and try this out. Okay, and then after that, you can pause the video and try this out. And then there are answers over here. Okay, so go back and forth between the answers. Okay, this is an independent practice. Okay, let me do this again. 1, 2, 3, 4. All right, so that is all I have for you for today. Actually, you can I'll have all this printed out and you can work from there. You don't need to really pause the video. Okay. All right. Have a good day. I'll see you maybe on Friday in Stanley Ho. And if I don't, then for whatever reason, then have a great break. Okay. Bye bye.